All right, good afternoon, everybody. Good afternoon. Yeah, love it when you guys say something back to me. All right, well, hopefully your first day was good. On to day two. Always feels like Groundhog Day when we do this Tuesday with a Monday schedule thing. But yeah, so any progress for those of you that were trying to get either clickers or note packets from the bookstore? Or a couple of you able to get them, or? Okay, there's some people showed up and they still weren't available. Anybody in that case? Yeah, a couple. Okay, all right. How about, was that note packet specifically or clickers too? Both, yeah, okay. All right, how many people tried to get a note packet and haven't been able to get one yet? Raise your hand for that. Okay. All right, sorry about that, guys. This was yeah, they didn't order enough. This was a new system they were trying out. Instead of getting them directly from the print shop, buying them there, and they just didn't order enough ahead of time. So yeah, definitely feel free to use any means of taking notes today and until you get that note packet, meaning you can use devices until then, totally fine. And then how many people had ordered a clicker, but they're telling you it's not available soon? Okay, so we just got a few of those. Okay, I've emailed them and haven't heard back on when those are coming in. So it's up to you if you can find them on Amazon. You might just want to do that. I don't know if you'd already paid for it through the bookstore or whatever, but you can, yeah, but yeah, I don't know what did they tell you when they'd be expecting them? No, okay, I'm not sure either. All right, sorry about that. But with that, because there's an issue there, I won't count these first few days against you. Actually, I know pretty much everybody's here because we have exactly, yeah, I know almost everybody's here in class. So I'll just give you guys the credit for being here those days. So yeah, so that's pretty much that. Hopefully everybody did the reading quiz that was due right now, 1:30. And that'll be the case typically at the beginning of each week. So we'll have another one on Wednesday next week over the material. And again, that's over the material for the whole week. Okay, so about how long did that take you yesterday? Throw some numbers out for me. I'm curious. 5 minutes, 2 hours, 5 hours, 20 minutes. Okay. Yeah, maybe 30-ish minutes.
Yeah, 30.
Okay, all right. That's good. That's not too bad. Okay. All right. This is a new system for us as well because the $500 textbook that we have used in the past came with an online system where we did quizzes there. So this is a new setup as well. So just kind of gauging you on how long those took. So some will be a little longer, some will be a little bit shorter than that, but okay. Yeah, and then for Friday we have our first lecture quiz that's due. Again, that's on your own. Okay, you don't take that in class. You don't need honor lock for that quiz, but I do want you to, you'll need to complete that honor lock practice quiz before it lets you take the next one. And again, that is just for you to get your computer ready to go for that honor lock system. Okay, and so if it's not letting you do it, then there's a little chat thing right there. When you're using honor lock, you just start chatting with the tech support people. They'll walk you through the steps on how to get your computer ready to go. And that's how it works. Okay, so that's the whole point of that. Okay. And then that lecture quiz is due Friday by 11:59 p.m. And it's over what the notes from yesterday, which this is the last one of those, as well as the ones we're doing today. So that quiz is open. So after today's class, then you'll have all the information you need for that quiz. But again, like I said, don't go into that quiz without studying. You definitely want to study for it like you would an exam. Even though you do have your notes in your book, you're able to use those. You won't typically have enough time to look everything up if you haven't studied ahead of time. Okay. So that's pretty much what the rest of the week looks like. No lab today, as I said yesterday. Labs will start next week. Okay. Any logistical questions or any questions by anybody? Yeah, go ahead, Faith.
So the slides for the lab.
The handout part, or
They're just like,
oh, did you go under Professor McGaw's page?
yeah.
Yeah, he's got all kinds of stuff in there, so he'll explain that to you. He's super excited about being in lab. So it can go either way. Yeah, he really does. He's mostly geared towards the section that he's doing, but it's all the same stuff that you guys are learning. So, but he'll send some specific comments in there, like, you guys did great on the last quiz. This is your average and stuff. So that won't apply to the other section, but they're all great resources. So all of that's kind of extra stuff that you don't necessarily need for a lab. But the main thing you need for lab is the handout that's in the module where it says lab materials. If you go into Professor McGaw's page, he's got all kinds of extra videos and stuff to help you learn and study, but none of that is required. It's really just the lab handout that's required. So, yeah, good question. What else? Any other questions? Okay, well, why don't we start with this? I want you to turn to the people on your team. This is another buffering system, right? We talked about the phosphate one on the slide previous to this. This is a different one, the bicarbonate buffering system. Just walk through these and fill in those things on with the letters there, which one's the acid, which one's the base. And then when there's a disruption in homeostasis, meaning that pH went down, the answers for the two options here would be which way does that equation have to move to help us, right? So let's do on your clickers this one, right? So you're going to use these two as your options. Which way does the equation move, right or left, when pH decreases? Okay, but I want you to talk about all of those things as a group. I don't have the clicker thing open yet. Oh yeah, so just hold down that power button. Your partner might be able to help you there. Yeah. So yeah, if you just got your clicker, hold down that power button until it starts flashing, then press A and then B.
Oh, it's working now?
Yeah, I just turned it on.
And it's the first question, when did pH decrease?
Yeah, that's the one I want you to send in. Yeah, but go ahead and answer all of them in your group.
So previous class, when I registered it under my name, do I have to do it again?
I don't know. When was it?
Genetic last fall.
Last fall.
It's the
You-
same clicker.
Yeah, you do have to still connect with our class. So
Okay.
go on you just go and you log into your account and you just add a new class.
But past days will show up under my name if I do that.
Yep.
Okay.
Yeah. Anytime you used it. Yeah.
Because they have pH, like the opposite of pH, so pH decrease.
So I'd love it if all four of you were talking together. There might be somebody that really doesn't get this and somebody else in the group that does. So I'd love for you guys to help each other out. Yeah.
So for the decrease in increases, is it asking like if the pH is decreasing, which way is it going?
Yeah. If the problem that we started with was pH went down too far,
Which way do we want it to go?
which way will that go in order to help that situation,
Oh,
like
okay,
to
so
fix that problem?
Okay.
Yeah. Mhm. Yeah. So the question is asking, which way will that equation move to help fix the problem of too low of a pH, right? That's the one you're sending in on the clickers. I want you to talk about all those questions there.
Are we on?
AB, yes. Mhm.
That's not.
All right, guys, so make sure you go ahead and send in that answer to this one here. So it's either A or B, right or left, okay? There's a bunch of other questions you answer, but the one I want you to send in is the answer to this one here, okay? Using these as your options. Okay, so we got about 30 of you. Anybody else? I'll give you about 10 more seconds to just send it in. If you have no clue, just hit a button so I know you're here. You won't get penalized for not getting the right answer. So up to 35. Anybody else? So we got about 70% of you saying B, which would be to the left. And then about 30% of you saying A, should be to the right. So let's walk through those top questions first. Okay, so which one's the acid? Which letter? A. Good. A for acid. Okay, but it's the one that's how do you know? Yeah, it has no H plus next to it. It's the one by itself in the equation, right? So it's the one sitting there by itself. So then which one is the base? B, yeah, so the one next to the hydrogen ion. Okay, so then in this situation of a too low of a pH, what does that mean for the concentration of hydrogen ions? We have a lot of hydrogen ions here or not enough? We got a lot, right? Yep, so that's that whole negative logarithmic thing. So we have a high hydrogen ion concentration, right? The little brackets means concentration. Okay, high hydrogen ion concentration. All right, so we got too many of them. So which of the two components of that buffering equation helps when we have too many hydrogen ions? So in other words, which one can help us soak up those hydrogen ions? Acid or the base? The base, okay, the base. So this one right here, right? So again, like we talked about last time, we got all these extra hydrogen ions floating around, and we can take this HCO3 negative, we can add that H plus to it, and then what does it become? How many H's do we have? 2, okay. CO, and what's our charge now? Neutral, right? So the part that's a little tricky about this is that's the acid, right? So some of you might be wondering, why would we want to make an acid if we have a problem with too many hydrogen ions, right? Is anybody wondering that? No, nobody's wondering that? Okay. All right, well, I'll talk about it anyways, because I know it confuses people. Again, this is that measurement. The pH is the measurement of free hydrogen ions, not ones that are bound to things, right? So if it's stuck onto the H2CO3, then it doesn't affect pH, right? And so that's the nice part about a weak acid, is when it's in a situation where there's already kind of a lot of hydrogen ions around, it's not going to release that hydrogen ion, right? Weak acids don't have to always release their hydrogen ions, okay? So since it's now bound to that H2CO3, it doesn't affect pH and it's been neutralized, right? We've kind of soaked up one of those hydrogen ions, okay? So that's, so which way does it go? Right or left? Was 70% of you right? Correct? Sorry, I should use the word correct. Yeah, yes, it does. Left is correct here. Okay, if we have the other problem, pH increasing, means we don't have enough hydrogen ions, right? So we got low hydrogen ion concentration. Okay, if we don't have enough hydrogen ions, which of the two components of the buffering equation help us with that?
The right.
The acid or the base? The acid, yep, the acid can dissociate, give off its hydrogen ion, right? And add hydrogen ions to the solution. And that is really meaning that the equation moved to the right, right? Went that way, dropped off its hydrogen ion, that got added to the solution, helps bring our pH back down or our hydrogen ion concentration back up. Okay, definitely important concept. Questions about that at all? Okay, definitely practice that. Make sure you got that down. Talk to your people on your team about that before you take the quiz, because there'll definitely be questions about that on the first quiz. Okay. The kind of last part of this is this buffering equation has this other side to it right here. Okay. So this is how it's really working in our body most of the time is, so for in the example of exercise, right? So let's say you wanted to go down, check out the cliffs. So you went down to Young Hall, went down the cliffs, you were down there for a while, and then you wanted to come back up the hill, and you're like, I'll just run up the hill, okay, instead of walking, right? How many people have tried to run up that hill yet? Yeah, okay, it's hard, right? It's a steep hill, okay? So if you would do that, you would definitely use what's called your glycolytic system, which forms lactic acid when you do that, okay? So you'd make a bunch of lactic acid. You would drop your pH down a little bit when you did that. So you would move that buffering equation to the left, right? But really in the body, we don't just stop right here. This carbonic acid dissociates into water and CO2, right? And then what happens to that CO2? What do you think? We breathe it out, absolutely. So where's the CO2 go? We breathe it out. Okay, and so the cool part about that, or kind of the tricky part about that is, now we can't make that equation go back to the right, right? So we kind of deal with hydrogen ions by getting rid of CO2, which doesn't have hydrogen in it at all, right? But since we got rid of one of the components of that equation, we can't drive it back to the right and remake that hydrogen ion. So that helps us maintain our pH. Okay, and that's why we breathe heavier too. Partially why we breathe heavier is to get out extra CO2. Obviously, also need to get in more oxygen as well. But, okay, questions on any of that? Okay, all right. Well, we're going to hop over to the second set of notes, which is on the chemistry stuff here. Okay. Don't hold me too accountable for being a chemist because I'm not, but we got to do a little bit of chemistry here before we keep moving forward. So this is just a verse that I love that kind of talks about what I was talking about yesterday with the idea that studying the creation, studying what God created, can actually tell us something about God, right? And so since the creation of the world, God's invisible qualities, right, his eternal power, his divine nature, have been clearly seen, right, being understood from what has been made, so that people are without excuse. So we all know something about God just by knowing something about what he created, right? And the body is a perfect example of that. And we get to do a lot of that this semester. So, all right. So we're going to talk a little bit about chemistry. Let's start out with a couple review questions on the clickers, just to make sure we're on the same page with how we do pH calculations here. Go for it. Feel free to talk to the people on your team. Just double check, make sure you got the same answer. And you can always change your answer on the clickers. Whatever you put in last is the one that counts. Okay, maybe about 5 more of you, I think. Go ahead and send that answer in. Okay, looks like we got everybody. So 94% of you are saying E, both B and C. So B would be the scientific notation form of that, and then C would be the decimal form of that. So we just move that decimal place over 9 times from 1, and we get that number. Okay, all right, let's do this one then. Okay, go ahead and send that answer in whenever you're ready. Again, check in with your partners, make sure you're on the same page. All right, looks like we got everybody. So about 80% of you are saying D. And then we got about 20% of you saying E. Okay, so D would be both A and B. So a pH of 2 is more acidic than a pH of 8. That is definitely true. The lower the number is, the more acidic, the more hydrogen ion concentration we have. And then B would be means there are 10 times more hydrogen ions than a pH of 3. That is also true, right? So that's the logarithmic part of it, that a unit of 1, movement of 1 is the equivalent of a 10-fold difference, right? Okay, good. So that is A and B, which was D. Good. Okay. Questions on any of that? Okay. So this is from an older song. How many people remember the band Gungor? Anybody? Any more? Couple? Gungor. The last name of those 2 people there, Gungor. Yeah, just a couple. Okay. Their famous song that got them really popular was that "Beautiful Thing" song, which a lot of churches still play. But this was one of their other songs. I'm not gonna play it. But some of the lyrics are pretty cool, and it makes me think about chemistry and about kind of what we talk about. So yeah, a couple of the key phrases here. They're pretty much talking about this idea that humans are made of the same material that the stars are made of, right? So I am mountain, I am dust, constellations made of us. And then this is one of my favorite lines as well. And we'll talk a little bit about carbon today, but a little bit more later. This idea that we're momentary carbon stories, right? And the kind of the cool part about the whole carbon kind of cycle is that we're constantly taking in things made of carbon. We're going to talk about organic molecules more, fats, proteins, lipids, carbohydrates, or fats and lipids are the same thing, and nucleic acids. But those are the carbon-based molecules. And we break those down, we make energy, we make our bodies. And then plants then absorb our CO2 that came from that, right? Then we eat the plants, or animals eat the plants, we eat that. It's just kind of this constant cycle of carbon. And so, yeah, just kind of a beautiful song. So if you're interested, Google it, look it up. It's a beautiful song. Okay, let's do this for a sec. Just a brief review on kind of atomic structure. So again, turn to the people on your teams and just fill this info in. Okay, as far as density goes, electrical charge, where would we find these? Yes or no, are they involved in bonds? Okay, go ahead.
Session 8 to 10 today.
There is, yeah, first one's tonight. Yeah, it's in ladder 102. I believe that's what it says. I have it on the Canvas page, right on that course overview module. It says the room number, but I believe it's 102. Yeah, yeah.
Thank you.
Mhm.
I know.
All right, sounds like most of you wrapping that up. So let's talk about each of these first. So as far as density goes, which of these are not very dense at all, very low density? Electrons, right? So very, yeah, so low density, okay? And these are definitely more dense, okay? Okay, when it comes to electrical charge, protons are what? Positive, neutrons, neutral, and electrons, negative, good, okay. When it comes to where they're found, which ones do we find in the nucleus? Okay, both protons and neutrons, okay, both those, and then where do we find electrons? Yeah, electron shell, so kind of in the outer part of the atoms, okay, and then which ones are primarily involved in bonds? Electrons, right? Definitely bonds for electrons. Okay. All right. Questions about any of that? I'm gonna close this. Okay. Questions about any of that? Okay. All right. And these are just kind of different ways to look at this, different ways to depict atoms, right? So kind of this planetary way to look at it, or this electron cloud model. But again, we'll kind of see the protons and neutrons in the center, in the nucleus, and then the electrons kind of floating around in this cloud outside. Okay, so let's talk about the electrons a little bit more. So the electron shells, electrons kind of, again, form this cloud around the nucleus. Shell 1, so there's going to be different layers, but the first layer, shell 1, can hold 2 electrons. Okay, as we see over here with helium. All right, we see over here with hydrogen, only has 1 in its outer shell. Helium has 2. So that means helium's outer shell is full, right? Whereas hydrogen could accept 1 more. Okay, but then every shell beyond that can hold 8 or more, even once we get further out. But mostly, for the most part, what we need to know for this class is the 8. All right, so it's really just that first shell that holds 2, and then it goes to 8 from there. How many shells? We can have up to 7 shells. And then this definition of a valence shell is really just whatever one is the last one, the outer one in each particular atom. All right. Okay, so this octet rule is this idea that you need to fill up that valence shell before you move on to the next one, kind of thing. And then the further we get out from the center, the less tightly bound those electrons are to the nucleus, because typically the positive charge of the protons will kind of help hold on to the electrons. The further out we get, the less effect we have of that. Okay, and so the more potential energy, the more possibility of them binding to something else. Okay. Okay, so let's talk about those bonds a little bit. So we'll talk about a few different types of chemical bonds here. Okay, so ionic bonds. Ionic bonds occur after the transfer of an electron. Okay, and that's the key part. The transfer of electron in itself is not the ionic bond. Right, so one atom gives up an electron to another one. So the one that gave it up is now has a negative charge. Now has a positive charge. The one that accepted it now has a negative charge, and now they're attracted to each other, so they stick together, right? That's an ionic bond. Okay, so there's kind of two steps there, right? First of all, the electron transfer. Second of all, now they're oppositely attracted, so they stick to each other. Okay, sodium chloride, the salt is the most common example of that. Okay, so we can see this here. Sodium gives an electron over to chloride or to chlorine. And then now chloride is negatively charged. Now the sodium ion is positively charged. Now they stick together. All right, so that's an ionic bond. Okay, so that's bond number one, ionic bonds. Questions there? Okay, number two, covalent bonds. So the defining feature with covalent bonds is that electrons are shared. Okay, so it's not that one takes one from the other one, but it's that they actually share. Okay, so we can have single covalent bonds, double, triple. Okay, so a good example of a single covalent bond is in methane gas. Okay, you see carbon there in the middle. All right, so carbon has 4 electrons in its valence shell, and it can have 4 single bonds with 4 different hydrogen atoms, right? Because hydrogen is going to have 1 electron in its valence shell. So now they're sharing there, sharing there, sharing there, and sharing there, right? So by adding 4 electrons to carbon, that valence shell of carbon is now full. But then by adding 1 electron to each of the hydrogens, all those valence shells are full too, because that one just holds 2, right? So that's oxygen is similar, O2, right? We have 1 double bond in oxygen. Oxygen has 6 electrons in its valence shell. So if we share 2, now they both have 8, right? Nitrogen, similar idea, but now a triple bond. There's 3 electrons being shared there between the 2 nitrogen atoms. Okay, so these are covalent bonds. Covalent bonds are typically the strongest type of bond, the hardest to break apart. Yeah. Okay, and then we got within covalent bonds, we have 2 different types, right? So we got the ionic bonds, we got the covalent bonds, and underneath those covalent bonds, there's 2 different types. It can be a polar covalent bond, or it can be a non-polar covalent bond. Okay, so a polar covalent bond means whenever we have unequal sharing of electrons. Okay, so it just means that the electrons spend more time on the side where one of the atoms is versus the other. Okay, so water is a perfect example of this, right? Water has this very large oxygen molecule and then these tiny little hydrogens. Okay, the hydrogens don't have much pull on the electrons because they're small. Oxygen has a lot of pull on the electrons. So the electrons end up spending more electrons end up hanging out over on the oxygen side and less of them on the hydrogen side. So we end up getting a negative charge on the oxygen side of the molecule and positive charges on the hydrogen sides of the molecule. And that's a polar molecule. Okay. So we get opposite charges within that molecule, but just on different parts of it. Okay, we're going to talk, there's a lot of biological significance with polar covalent bonds we'll talk about. Okay, it's really the main reason why water is the key to life, right? So the reason why we're 70% water has a lot to do with the fact that H2O molecule is polar. Okay, non-polar covalent bonds just mean that we share those equally. Okay, so smaller atoms or atoms of a similar size share more nicely, right? They don't try to hog the electrons. And so carbon is a very nice sharer of electrons, and that's why we kind of find it in all of these very important molecules, all the ones we call organic molecules, because it makes nice non-polar covalent bonds, pretty much most things that it binds with. Okay, questions on any of that? Okay, so we got the 2 broad types so far, ionic and covalent. Underneath covalent, we got polar and non-polar. And the last type we'll talk about is hydrogen bonds. Okay, so hydrogen bonds, in order to have a hydrogen bond, we first of all had to have a polar molecule. Okay, so we get the positive side of one polar molecule sticks to the negative side of another polar molecule, or it could just stick to something else that's charged. Okay, so the perfect example is water, right? So when water tends to stick to itself because of polar, first of all, because there's polar covalent bonds within each water molecule, but then second of all, because hydrogen bonds form between the water molecules, right? So we got negatively charged oxygen kind of sticking to the positively charged hydrogen of another water molecule, right? This hydrogen sticking to this one to this one, right? And that's why water sticks together, right? So when water is kind of dripped out of something, it kind of there's some resistance to it falling out if you go slow enough, right? Because it's holding on to it, so it's sticking together. And then when you put it on something, it also tends to bead up too. Instead of just kind of flatten out, it kind of beads up because it's sticking to itself. Okay. And this is really where we get water surface tension, right? This idea that it takes some amount of pressure to break the surface of water. Right? So you guys have all seen the pictures of those water strider bugs that can kind of walk on water, right? And you see the water actually kind of bending underneath their feet. That's because the hydrogen bonds aren't being broken, right? Their weight and their weight distribution isn't enough to break those hydrogen bonds. Okay, so those are the three types of chemical bonds. Go ahead.
So are polar covalent bonds stronger than non-polar covalent bonds?
Good question. Yeah, I don't think there's necessarily a differentiation there. I think it depends on which type of molecule we're talking about. Yeah, great question. But covalent bonds are the strongest of the three broad categories, but then within those two, I don't necessarily know if there's a distinct difference. Yeah, good question. Other questions on that? Okay. All right, so let's talk a little bit about chemical reactions. So what happens when things come together, right? So, or break apart. So any process that forms or breaks chemical bonds, right? So all those chemical bonds we just talked about, they happen via chemical reactions, right? Whenever any two atoms or more come together, that's a chemical reaction. And then just the same, whenever those atoms then come apart, then that's a chemical reaction as well. Okay, so when they're coming together, that's known as a synthesis reaction. Right? So we're taking smaller things, putting them together and making bigger things. Anytime you hear the word synthesis or synthesize, it just means like making something, right? Where we're making something bigger than what we had before, like a synthetic something, right? That's something that we made, okay? And then the opposite when we break those apart is decomposition. Okay, so the molecule is broken down into smaller things. Okay, good example of that is glucose. Glucose is our primary fuel in our blood, right? It's just a single monosaccharide, okay? But then we can't store it that way except for the stuff that's in our blood. Anybody know the name of the, we have it up there? Yeah, I don't. Anybody, actually I do. Here we go. So I was going to quiz you, but it's right there. That's the name of the stored version of glucose, which is really just a bunch of glucose molecules strung together, right? But they have to be bound to each other to make that glycogen. And so we have to go through synthesis reactions to turn glucose into glycogen. And then same idea when we have that glycogen stored in our liver and in our muscle. And then when we break it down because we need it, that goes through a decomposition reaction in order to turn it back into glucose. We can put it back into our blood and then we can use it in our cells. Okay. All right. Questions on that at all? Okay, so we're going to talk a little bit about water. So water, again, is one of these things that's absolutely essential for life. Okay, and so we're going to talk about some key properties of water here. All right, and all of these properties are due to the fact that hydrogen bonds form between water molecules. Okay, but before those hydrogen bonds could form between the water molecules, we had to first have polar covalent bonds within each water molecule, and then they'll stick to each other and form the hydrogen bonds. Okay, so let's look at the first property of water. Number one, it has a high heat capacity. Okay, so what that means is it takes a lot of energy to change the temperature of water. Okay, so a lot of energy absorption before the temperature actually changes. And that's kind of gets into the idea that what actually is temperature of a substance, and what the temperature of a substance is really just how fast those molecules are moving around. right? And so when we put energy into those, they start moving around faster and faster and faster, right? And eventually, it could go from liquid to gas. They're moving around so fast that it boils, right? And they pull apart from each other, okay? But when those molecules are stuck to each other via those hydrogen bonds, it just is harder to get them moving fast, right? Because they're kind of sticky, they're stuck to each other. So it takes a lot of energy to warm it up compared to other types of molecules. Okay, so some good examples of that. We got anybody from Phoenix area here? Yeah, got some Phoenix, yeah. So let's say in the winter in Phoenix, or maybe the summer, either one, what might be like a typical like swing if you look at the weather app, like high today versus low? Yeah, let's try winter first.
65 to 75.
Okay, 65, okay, all right. And then sometimes in the summer, we might get up to like 120, right, 115, right? And then at night, maybe it gets down to 85 or something like that. Yeah, sometimes on the worst days. Yeah. I did my doctorate at ASU and we lived in Phoenix as well. But in general, we can have a pretty big swing in temperature in the desert, right? And sometimes in summer, it can get really cold. I mean, sorry, in winter, it can get really cold at night, right? You can get in the 20s and stuff in Phoenix at night, but then during the day, might get up to 70, right? So it might go from like 25 or 30 to 70, right, in the day. So we might have like a 40 to 50 degree swing from high to low. Right, so somebody pull out your weather app right now and tell us the high and the low today, even though we're in the middle of a heat wave here in San Diego. But what is the high and the low today? McKenna's looking. 84.69. Okay, so we got about, what's that, about a 15 degree swing? Yeah, about a 15 degree swing. And that's pretty extreme for San Diego, right? Pretty much every time I fly home to San Diego, anytime I've gone somewhere, the pilot says the same thing. It looks like a nice night, 68 degrees, partially cloudy. It's pretty much always the same temperature, always partially cloudy. So when you're in a coastal climate, that's a big swing. 15 degrees is a big swing. Normally it's maybe 5 or 10 degrees from high to low, right? That's 100% due to the fact, not 100%, but mostly due to the fact that there's a lot of water in the air, right? There's a lot more humidity in the air, and the fact that we're sitting next to this gigantic cooler right next to us, which is the ocean, right? And it's hard to change the temperature of water. So the more water there is in the air, the less the temperature changes, right? So I have much smaller swings as far as high low goes in climates that have more water in the air, more humidity, versus in the desert when it's really dry, you can have these huge swings because there's not much water in the air, so the temperature can change pretty drastically. The other key example here is thermoregulation. Okay, what that means is kind of regulating body temp. Okay, humans are pretty good at regulating our body temperature, right? We stay right around 98.6, which actually we learned during the pandemic that is not really the average body temperature anymore. I don't know if some of you followed the news on that, but that's what everybody, that was established maybe 150 years ago. The 98.6 was the average body temp. And it's just not that anymore. Yeah, it's typically a little bit lower. It's actually about a degree lower than that, with billions of people checking their temperature all the time. They got a lot of data that they could look at for that. So it's actually about a degree lower than that. But the idea is that our body temperature doesn't change much at all. Part of that's because of the mechanisms we have to sweat and things like that. But a huge part of it is the fact that we're 70% water, right? And so most of our body is made up of a substance that it's really hard to change the temperature of. Okay. And then this one's a very related idea to that, but it's not the exact same thing. And this is the idea that this is property number 2, that it takes a lot of energy to turn water from liquid to gas. Right, that's called the high heat of vaporization. Okay, and the example with this one is that this is tightly linked to controlling our body temperature too, with sweating. Okay, so if you guys have been in a super hot, humid environment, do we have anybody from like back east, like North Carolina, South Carolina, anything like that in class? Anybody from the East Coast? No, nobody. Okay, all West Coasters. Okay, but it gets really humid back there, right? So I was talking to a student that's in North Carolina yesterday, and a lot of times it might be 90 degrees or so with 85% humidity. That's incredibly humid, right? And the problem with that for our bodies is that it's hard to put more water into the air when there's already a lot of water in the air, right? And the whole key of sweating is that the sweat that comes on our skin goes from liquid to gas on our skin, right? If it doesn't do that, if it just falls off, it's just a waste, right? Because it takes energy to turn that water from liquid to gas. And so when it goes on our skin as water, the heat from inside of our skin heats it up, turns it into vapor, and then takes that heat with it, right? And that's how we lose energy or lose heat from sweating. So if it doesn't do that, then we're just wasting water, right? And so the more humid an environment is, the more the sweat just falls off and doesn't actually vaporize on us, right? And so because of the fact that it takes a lot of energy to turn it from liquid to gas, means that when we sweat, that energy actually gets pulled out of our body and we cool down, right? And that's why sweating is so helpful for us to cool our bodies down. But it's got to vaporize. It can't just fall off. Okay, questions on that? Okay. All right, so we got 2 properties so far. Property number 3 is that water is a universal solvent. Okay, so that means that most things, most different substances we put inside of water will break down in some way. Okay, and really all reactions in the body need to be wet reactions, right? They need to happen in a solution in water. Okay, and the reason it's so good at breaking things down, again, is because it's polar, right? So when we put sodium chloride in water, the positive part of the sodium sticks to the negative part of the oxygen, right? And then the positive part of the water, the hydrogen side, sticks to the negative chloride. And then the water's moving around, so it just rips that sodium and chloride apart, right? And that's what it does. So it dissolves it, right? But it does that with ionic substances, does it with polar substances. It's only when we try to mix it with non-polar substances like lipids, fats, and oils, then it can't do that. Okay, so it's a universal solvent. All right, take a look here, and I want you to talk with the people on your team and decide which of these represent, well, let me first define them before I have you do that. Cohesion is going to be our property number 4, and then adhesion is going to be property number 5. Cohesion means something that sticks to itself, right? So it's cohesing, and then adhesion means you're like adding something else. So it's not sticking to itself, but it's sticking to something else. Okay, those are both properties of water. Talk through this, and yeah, let's see, maybe this question here. Which ones would be representing adhesion? Okay, so you can send those in your clicker, but talk about all 4 pictures with the people on your team. But just on your clicker, send in the one you think would represent adhesion. Go ahead, talk with each other.
And then what type of tree? Okay. Yeah.
And then. I think surveillance takes something else. They are.
All right, go ahead and send in the ones that you think are adhesion, or just the one, because I'm only letting you send in one, right? Could be more than one. Yeah, adhesion. How many we got? Couple more people, I think. Anybody else? Okay, there we go. All right, so we got almost half of you saying B, but then we got some D, we got some C, we got some A. So let's talk about those. Okay, so adhesion again means sticking to something else. All right, so with A, how many people thought A had some adhesion going on? Yeah, what's the water sticking to there?
The rim of the test tube.
Yeah, absolutely. Glass typically is negatively charged. And so we see what's called a meniscus in the fluid there, where the outside of it is kind of sticking to the glass, but then the inside kind of sags because it's not sticking to the glass, right? So that's definitely adhesion. Okay, so we definitely see some adhesion here. Okay. Anybody think that one was cohesion? Or anybody want to make a case for that one being cohesion? Okay, all right. Okay, what about B? We got some water on a spider web here. We got some little drops forming. How many people thought this one was adhesion? Yeah, it's sticking to the spider web, right? So definitely we got some adhesion there. But then when we look like specifically right here, that's some cohesion too, right? Because it's sticking to itself to form that drop, right? So we really got both on that one. Okay, what about C? Cohesion or adhesion? I'd say mostly cohesion, right? Because it's the water sticking to itself that gives us that surface tension that the water strider's legs just aren't put enough pressure on to break those hydrogen bonds. Okay, and then if we're just kind of looking at the water on the top of the grass here, how many people would say that one is adhesion? Okay, how many people cohesion? Okay, how many people don't say anything? Most of you didn't say anything. That's why I use the clickers. Okay, but yeah, so this one's mostly cohesion, right? Because it's kind of like sticking to itself. If you see some that's like hanging down there, then that might be some adhesion too. But yeah, so obviously this is there's a lot going on in each of these, but just wanted you to kind of think it through. But questions about any of those? So those are properties, the last two properties of the 5 special properties of water. Okay, another clicker question here. Talk with the people on your team about this one and have you send it in. Everybody turn around, talk with everybody, make sure you're on the same page. All right, about 10 more seconds. Everybody send something in. Okay. We're pretty much exactly 50-50 between B and C. Okay, what if we do it this way? What if I close that one and then let you put in more than one answer? Okay, so this is good practice for using your clickers. We'll do different types of questions like this. With this type of question, for the first letter, you can just press one of the letter buttons, but then you need to press, I think it's up to take you down to the bottom, and then you can kind of just scroll through and put another letter next to it. Play around with that for a second. See if you can get that. Or to the right, maybe, I'm not sure. You press one of the arrow buttons and it'll take you down there, and the cursor's down there, and then you can scroll through the alphabet for the second letter. And then when you're ready, you just hit the send button. You have to hit the send button with this type of question. If you're not sure how to do it, maybe your partner figured it out. Got it?
I don't know if I need to make batteries.
Oh, it's dying out on you.
I've answered like half the
Okay.
question.
Sometimes if you take the back off and just kind of spin the batteries around, that helps.
So I've sent something in already, but you pressed
That's
A.
perfect. Then just hit the send button whenever you're ready.
And so like, say if I were to like not do it,
Uh-huh.
I would just have the A and then do a little dash thing. Is that how I do it?
Or just hit send after you press A, yeah,
Okay.
without anything, yeah, yeah. Mhm.
Thank you.
Yeah, so make sure you hit that send button on your clickers with this type of question. That's what you'll see, a little check mark after you click that button. Okay, so we got maybe 3 more of you that didn't quite get in there. Everybody hit send. There we go. Okay, just about got it. All right, so 40% of you said BC. Oh, and then another 20% of you said CB. So 60% of you are saying these two, right? And I love that because that's correct, right? So in order to have hydrogen bonds between water molecules, we first of all had to have polar covalent bonds within the molecule, within each molecule, right? Between the H and the 2 H's and the O, right? Okay, good. Questions on that? Definitely an important concept. Okay, all right, one more. I want you guys to talk about this as a team. All right, so what's the difference between high heat capacity and high heat of vaporization? Are they related? Are they the same thing? Kind of chat about that for a second, see what you come up with, and we'll come back together.
I think.
All right, guys. So yeah, just a couple things here. They're definitely related, right? They're both caused by the same thing of these polar covalent bonds and the hydrogen bonds between. They're both related because they're related to temperature, right? The one is just specifically about any temperature that water's at. It's hard to change its temperature. But then heat of vaporization is just kind of very specific, right? It's like the changing the temperature just from liquid to gas. That takes a lot of energy. So it's just heat of vaporization is like a little bit more specific, kind of a very similar idea of high heat capacity. Okay, questions about any of that? Okay, let me just show you 2 things before we finish up here. Or number one, I wanted to, let me go back to the computer here. Number one, I wanted to turn your attention to the review session tonight in Ladder 102. Okay, 8 to 10 p.m. Show up to Ladder 102, show up with your questions about the material, or just show up hoping to gleam off of other people's questions. Either way, you're welcome either way. Okay, so yeah, so definitely show up for that if you want to get some help. Secondly, if there's any of these concepts you're kind of having a tough time with, or you just want to get ahead of this, don't start packing your stuff up yet, guys. Please listen. Okay. You can click right there where it says tutorial services, okay, right here, and you can sign up for a tutoring session. They have some online tutoring, but they also have face-to-face tutoring with students who've had this class, and that can be super helpful, okay? And then the other thing I wanted to show you was this. Most of you have done this, but if you have a clicker and you haven't done this part yet, you need to register your clicker, okay? So some of you have already done it, you're set, but then there's quite a few of you that I have responses from your clicker, but I don't have you in my system, okay? So that means that you probably haven't done this part yet, okay? So there's 2 steps to it. Number one is you make an account on iClicker.com, okay? Make an account, sign up. You're gonna connect with Point Loma, okay? You're gonna put in your information when you do your account with your student ID, okay? And then you have to find the class, okay? So our class, oh, I didn't update this one. I updated the PDF that I sent you guys, but it's just bio 1030 2022, okay? And you'll see that I'm the instructor, okay? So you have to connect with our class. That's step number one after you make the account. And then step number 2 is you got to make sure your remote ID is in there, okay? So on the back of your clickers, there's this little sticker that has a 8-digit number, okay? If yours is all rubbed off like mine is, let me show you the secret. You turn it on, the first thing you see there is the ID. Okay, so if you got to use one or somebody's from somebody else, you might not have that sticker there, but it's the first thing you see when you turn on. Okay, so you got to both register yourself to iClicker, connect to our class, And then make sure you've added your clicker to yourself, so all your points match up, okay? All right, guys, have a fantastic day. We'll see you on Friday.
Thank you.
All right, have a good one. See you. Yeah, sure.
So, I'm gonna be at my cousin's wedding in October.
Okay.
And it's kind of like the state, we're gonna be, I'm gonna be gone, I think it's like a Tuesday to a Thursday.
Okay.
So I was wondering, is there a lab Monday I could possibly do?
There are no Monday or Friday labs.
Okay.
There's
so is there
only
any-
Tuesday, Wednesday, Thursday labs.
Okay.
What, do you know the exact date?
Yes, it is the wedding is the 20th. The 20th. But if you want, I can also come to office hours to.
Yeah, we can take a quick look here. So the week of October 25th, probably. Yeah, that one is, it's a dissection day, so, yeah, it's a better one to miss because you're not leaving the partner, well, you're not, you don't have a worksheet you're turning in that day, but you will miss a good chunk of the cat dissection. So, yeah, you might just kind of leave your partner to do the dissection by themselves that day. It's a little challenging, but yeah, just remind me and whoever your lab instructor is when we get a little bit closer.
Did that change any of my points or is that necessary?
Yeah, I mean, yeah, we'll have to see. Most likely not. We got a good reason, but yeah, yeah,
alright,
okay.
thank you.
Thanks for letting me know. Yeah, go ahead. You can just try to get it, get it done by the end of the week. It's worth that, yeah, through Canvas and it's over the